Assalamualaikum warahmatullahi wabarakatuh. For lab 3 transistor, I will conduct the part 1 experiment. This lab experiment purpose to verify some important electric characteristics of bipolar transistor. Okay, for this experiment, we use power supply, potentiometer, ammeter, resistor, NPN transistor, multimeter, voltmeter, resistor, ammeter, and power supply. Okay. The circuit was connected as shown here. We want to measure the IC current to determine whether VCE or IB that have greatest effect on IC. Okay, we will measure when the ammeter at 0 ampere, 25 microampere, and 50 microampere. This potentiometer function used to set the ammeter value, and this resistor function to ensure that base current always at low to avoid transistor damage by the excess supply of voltage. Okay, now before we start the experiment, set the ammeter at 0. Battery at 0 volt. Then we run the circuit. As we can see here, the IC current 0 ammeter when the IB 0 ampere and the battery supply 0 volt. We increase the battery supply to 0.5, still 0 ampere, IC 0 ampere. At 1, 0, 1.5 volt, 0 ampere, 3 volt, still 3 ampere, still 0 ampere, still 0 ampere, 12 volt, still 0 ampere, okay, we can see when the DC power at 15 volt and ammeter at 0 ampere, IB 0 ampere, IC will be 115 nanoampere. Okay. Next, when the voltmeter at 18 volt, the IC 138 nanoampere. Okay. Key in the data. Next, we change the IB ammeter at 25 microampere. Okay. We need to estimate the value at potentiometer to ensure the ammeter, IB ammeter at 25 microampere. Okay. Okay. Increase, okay, 25 for 19 microampere. Start with 0 volt. Run the circuit. Okay, we can see the IC 0 when the voltmeter is 0. When the VCE at 0.5 volt, the IC will be at 1.78 microampere. We do this experiment, we slowly increase the VCE from 0, 0.5, 1.0, 1.5, 3, 6, 9, 12, 15, 18. We key in all the data of the value of IC here. Then after finish, we change the IB value to the 50. Okay. Okay. When we see it at 0.5 volt and IB at 50 microampere, the IC will be at 1.78 microampere. Slowly increase the data, VCE data to from 0 to 18. Okay. When VCE at 18 and IB at 50 microampere, the IC will be 66.34 microampere. In review question 3, calculate beta, which is current gain from base to collector. The formula to calculate this is IC over IB. In the question, one way to calculate current gain from base to collector for VCE equal to 10 and when IB equal to 50 microampere. So we set up this to 50 IB to 50 microampere and VCE at 10 volt. Next, we run the circuit. Okay, we can see the value is 36.96 microampere. Okay. So 36.66 microampere divided by 51.54. 51.54 microampere. So equal to 0.717. The curve also observed can be observed also using oscilloscope. The circuit was set like shown here. Okay, the DC power set at 0 to measure when IB equal to 0. So let's run. Okay, now we can see the curve when IB equal to 0. So next we change when IB equal to 25. 25. Okay, This is the circuit when IB equal to 25 microampere. And next, we change to the 50 microampere. Okay, this is nearest that I can get. As shown here is the circuit when IB equal to 50.
Moving on to part 2 of experiment 3. So this part of the experiment, we are going to test the characteristic. We are going to see the characteristics of N-channel junction field effect transistor. So basically, this circuit shows the lead location for the transistor, which is here. So the component used here is here are transistor. This N channel 2N4 to 2N4 to 2N4092 model. This is voltmeter, ammeter, and this is power supply. So after the circuit was built, student will measure the drain, this drain to source voltage, which is VDS here. So first of all, we're going to set up this volt for 0. As you can see, there is no value obtained here in ammeter and also voltmeter. So I'm going to increase the power supply until this BDS here shows 0.5 volt. So I'm going to put 3.316. As you can see, it shows 0.5 volt here. If we change it to volt, it will be 0.5 volt. And the reading here shows 10.43 milliampere. And if we change it to, if you want to get 2 volt here, we have to change the power supply as well. So I'm going to change it to 10.33. And we got the 2.00 V value right here. And the ammeter also shows the value, which is 30.83. So for the result, I already put in the table like this. And this is the graph that I plotted. So basically, this graph, this output characteristic define the relationship between the two output, which is VDS and also ID. It is the relationship between the drain current ID and the voltage VDS. So the value here, we call it as IDSS when it is IDSS actually the value when the flat part of the curve occur. So student obtaining the value of IDSS here around 34.86. So this is the FET curve tracer circuit. The component used here are signal generator and channel, resistor, diode, and also oscilloscope. This oscilloscope was added to observe the characteristic of the curve. So basically, the curve tracer work by applying a swept voltage to separate terminals that are being tested. So it will determine how much current can flow through the DUT at each voltage. So I'm going to set this immersion first. As you can see, it went out. And after this, it will become flat. So here it becomes flat. If we compare this to the graph that I've plotted before, it's basically the same. It shows the same result as the when it started to reach the IDSS, it will become flat. So next, this is the FET curve tracer circuit with gate supply. The circuit I use is the same as before, but the signal generator, the voltage different, which is I use it different, which is 12.6, and I put the power supply here, and I also use the oscilloscope to see the output. So basically, first of all, I'm going to turn off this power supply to 0 first. As you can see, there is as you can see, there is a 0 reading here. The trace become a horizontal line. We're just going to wait for a moment. As you can see, the trace becomes 0 here. If I change it to 3 volt, it will also become a horizontal line. If I change to 5 volt, also become a horizontal line. So this basically shows that the transistor is not conducting any current. The channel has been cut off by the gate voltage. So as for the gate voltage, when their terminal are connected to a circuit, they will normally conduct current across the drain to the source without providing any voltage to the base.
Assalamualaikum and a very good day. Now I'll be doing a lab 3 transistor, which is part 3. Here we can see is N-type channel, which is only electrons are used. So this JFET operates in depletion mode, which is the control voltage at the gate terminal will remove the carriers in the channel, and then the transmitter will then conduct the source terminal to the drain terminal. So then when the gate is negative, the free electron will then push out of the channel, which cause the free carriers to become a little. So the higher resistance in the channel will make the source and the drain current to become decreased. So if the gate is negative enough, so this device will be turned off and the current will not flow. So this cause the circuit to be to has a sudden drop voltage. However, there are a few errors in this lab. There are supposed to be a sudden drop, but one of them. But here we can see, as I slide the potentiometer, the voltage will become increased, and the range of the potentiometer is from 98.98 microvolt to 5.85 millivolt, which same as the in the lab manual, which is 0.75 volt to 0.91 volt. So that's all from part 3. Thank you.